The OASIS system enables situated object-aware interaction in the home. It leverages advances in computer vision and interactive display technology to address key design issues in hybrid physical-virtual systems. Real-time computer vision techniques identify and track household objects. When an object is placed on the counter, it is recognized by the system and its identity is displayed. Next to the label, an entry point to interactive functionality is projected. This displays a menu of actions and information that are specific to the context provided by the object. In this case, the orange is being added to the grocery list stored in the system. Actions can also be launched without an object, and later have a scope applied. Here, a full grocery list is being viewed. An object can be introduced to explicitly provide context to scope the actions available, acting as a filter on the list. When it is removed, the context returns to the general state and the filter clears. To interact with objects that are not always physically present, it is necessary to be able to create and manipulate virtual objects. A virtual object can be made from a physical object by dragging the interaction point away from the object. A copy is created which can be manipulated independently, while still presenting the same functionality as the original. Virtual objects can be stored for quick access in a drawer, or brushed off the front of the counter to be discarded. In the event that the object recognition system incorrectly identifies an object, the label can be touched to correct it. The most likely identities are presented, as determined by the object recognition system, or an entirely different one can be entered manually. This correction process can be used as training data for the recognition system. A similar approach is used for creating a new virtual object without a physical object to copy. A blank object is dragged out from the drawer, and a new identity is entered. Action is normally taken only in response to explicit user input. In special cases, though, action can be taken proactively based on the context provided by the observed objects. Here, a container of ice cream triggers a timer to warn against melting. Only actions that do not require an explicit undo request by the user are eligible for automatic instantiation. Objects can be grouped together transiently to form collections. Collections are formed opportunistically based on physical proximity, and can be created and destroyed quickly by moving the physical objects. They present functionality that is scoped to the contents of the collection. In this case, recipes are presented that include all of the ingredients in the collection. Similar to a virtual object, collections can be saved for later access. This provides a persistent shortcut to the context defined by the collection. The interplay of physical objects and digital artifacts provides the potential for interesting interactions. A recipe can provide help with difficult steps by displaying guides on the surface, such as the steps to juliana pepper as seen here. Finally, a timer is brought up to help with cooking.